Okay, we're looking at the last lesson of 9.6, which is just solving exponential and logarithmic equations. Jumping right into the examples with number 1, we have 3 to the x plus 2 equals 7. This is an exponential equation, so in order to solve an exponential equation, we have to use a logarithm. And I can tell that this is exponential because my variable is an exponent. So the first thing I need to do is I need to figure out what my exponential base is. And my exponential base is 3. Because my exponential base is 3, I'm going to use a log base 3. So I'm going to apply a log base 3 to each side of the equation. So I end up with log base 3 of 3 to the x plus 2 equals log base 3 of 7. On this side, because my log base and my exponential base are the same, it will equal my exponent. So this side ends up equaling x plus 2 equals log base 3 of 7. Then to solve for x, I subtract 2, and we end up with x equals log base 3 of 7 minus 2. And then if we simplify that, x will equal a negative 0.2288. And that will be my final answer. Looking at example number 2, again we have an exponential equation. We have 8 times e to the 2x equals 20. Again, I can tell it's an exponential equation because my variable is an exponent. The first thing I actually have to do here is I have to get the e to the 2x by itself. So I have to get rid of the 8. So my first step is going to be to divide by 8 on both sides. This leaves me with e to the 2x equals 20 divided by 8 is 2.5. Then I see that my exponential base is e. Well, that means we need to use a log base e, and log base e is natural log. So I'm going to apply a natural log to both sides of the equation. So I end up with ln of e to the 2x equals ln of 2.5. Now again, natural log has a base of e, and when my log base and my exponential base are the same, it equals my exponent. So this side simplifies down to just 2x equals the natural log of 2.5. Then to solve for x, we're going to divide by 2 on both sides, and then x will equal, when I simplify the natural log of 2.5 divided by 2, we end up with 0.4581, and this is our final answer. Moving on to number 3, again we have an exponential equation because I have e to the 3 minus 2x equals 4. Again, my exponential base is e, so I have to use a log base e and which is natural log, and put a natural log on both sides of the equation. So I end up with the natural log of e to the 3 minus 2x equals the natural log of 4. Again, since the natural log has a base of e and my exponent base is e, this side simplifies to 3 minus 2x. So we end up with 3 minus 2x equals the natural log of 4. And then it's just a regular equation. So I solve for x by first subtracting 3. I end up with negative 2x equals the natural log of 4 minus 3. And then I divide by negative 2 on both sides. So when I do that, x will equal 0.8069, and then that will be my final answer. When you plug this into the calculator, make sure you do the natural log of 4 and the parenthesis, then subtract the 3, and then divide by negative 2. Looking at number 4, it looks a bit more complicated. I have e to the 2x minus e to the x minus 6 equals 0. Again, I'm dealing with an exponential equation because my variable is an exponent, but it kind of almost looks like a trinomial that has to be factored. and it kind of is. So what we're going to do is we're going to do substitution. We're going to go ahead and let a equal e to the x. If I do that, because this first one is e to the 2x, this would end up being a squared minus a, because e to the x we're saying is a, minus 6 equals 0. Then from here, I factor. I'm looking for two numbers that'll multiply to equal -6 and add to equal -1. And those two numbers are going to be -3 and +2. So we end up with a minus 3 times a plus 2 equals 0. Then we set each factor equal to 0 to solve. So a minus 3 will equal 0, and a plus 2 will equal 0. So then a will equal 3, because I'll add 3 to both sides, and a will equal -2, because I'll subtract 2 from both sides. But remember, we had substituted a in, and a actually equals e to the x. So this is really e to the x equals 3, and e to the x equals -2. Again, these are still exponential equations because my variable is an exponent. Because my exponential base is e, I need to use a log base e. So I'll apply a natural log, because log base b is natural log, on both sides. So I end up with the natural log of e to the x equals the natural log of 3. And then the natural log of e to the x equals the natural log of -2. Again, because natural log has a base of e, and when my log base and exponential base are the same, it equals the exponent. I end up that x equals the natural log of 3, and x equals the natural log of -2. We cannot take the log of a negative number, so that solution will not work. I can take the natural log of 3, and x will end up equaling 1.099, and then that is my final answer. Looking at number 5, we have 3x times e to the x plus x squared times e to the x equals 0. This is again an exponential equation because again, I have a variable as an exponent. I have two terms here. I have 3x times e to the x and x squared times e to the x. Both of them have an e to the x in each term, so I'm going to factor out an e to the x. That will leave me with 3x plus x squared equals 0. Then again, I'm going to separate each factor. This is e to the x is a factor, 3x plus x squared is a factor. I'll end up with e to the x equals 0, and 3x plus x squared equals 0. With e to the x equals 0, again, I have an exponential base of e, so I have to use a log with a base of e, so I have to use natural log. So I end up with the natural log of e to the x equals the natural log of 0. Again, because natural log has a base of e, and when my log base and my exponential base are the same, it just equals the exponent. So I end up with x equals the natural log of 0. We cannot take the natural log or any log of 0, so that solution will not work. But then over here, I have 3x plus x squared equals 0. And again, I still have two terms. I have 3x and x squared, and those two terms both have an x in common, so I can factor out an x, which will leave me with x times 3 plus x equals 0. And then again, we set each factor equal to 0. So we set x equal to 0, and we set 3 plus x equal to 0. My first solution, I have x equals 0, and then here I can subtract 3 from both sides, and x will equal -3, and that will also be a solution. So we end up with two solutions here. We're going to stop here because those were all of the exponential equations, and then we'll solve the logarithmic equations and the application equations in a different video. Thanks!